Today's topic is solving systems of equations by substitution. Let us solve this system of equations by substitution. In solving a system of equations by substitution, we solve for x or y in one of the equations and then substitute in the other equation. In this system of equations, y plus 1 is equal to 2x is equation number 1. 3y minus 4x is equal to 3 is equation number 2. Choose the equation that looks less complicated. The first equation, y plus 1 is equal to 2x, looks less complicated than the second equation, 3y minus 4x is equal to 3. So, y plus 1 is equal to 2x. In this equation, it is easier to solve for y than to solve for x. So, solve for y. Transpose positive 1 to the right side. Change its sign from positive to negative. So y is equal to 2x minus 1. Substitute 2x minus 1 for y in the second equation. So substituting 2x minus 1 for y in the second equation, we get 3 times the quantity 2x minus 1 minus 4x is equal to 3. Using the distributive property of multiplication, we get 6x minus 3 minus 4x is equal to 3. 6x minus 4x is equal to 2x, and then minus 3 is equal to 3. Transpose negative 3 to the right side. Change its sign from negative to positive. So we have now 2x is equal to 3 plus 3. This is now equal to 2x is equal to 6. Divide both sides by 2. So x is equal to 3. Substitute 3 for x in the first equation. Y plus 1 is equal to 2x. This is now equal to y plus 1 is equal to 2 times 3. Y plus 1 is equal to 6. Transpose positive 1 to the right side. Change its sign from positive to negative. So we get now y is equal to 6 minus 1. Y is equal to 5. So the value of x is 3 and the value of y is 5. So the solution is 3, comma 5. 3 is the value of x, 5 is the value of y. Let us check. This is the system of equations. The first equation is y plus 1 is equal to 2x. The second equation is 3y minus 4x is equal to 3. We got 3 for the value of x and 5 for the value of y. Substitute 3 for x in the first equation and 5 for y in the first equation. So 5 plus 1 is equal to 2 times 3. This is equal to 6 is equal to 6. This is a true numerical statement. And then substitute 3 for x in the second equation, 5 for y in the second equation. So, we have 3 times 5 minus 4 times 3 is equal to 3. 15 minus 12 is equal to 3. 3 is equal to 3. This is a true numerical statement. This means the answers are correct, meaning the value of x is really 3 and the value of y is really equal to 5. Let us solve another system of equations by substitution. In this system of equations, 2x plus 4y is equal to 14 is equation number 1. X minus 2y is equal to 3 is equation number 2. Choose the equation that looks less complicated. The second equation, x minus 2y is equal to 3, looks less complicated than the first equation, 2x plus 4y is equal to 14. So, we write x minus 2y is equal to 3. It is easier to solve for x than y in this equation, so we solve for x. Transpose negative 2y to the right side, change its sign from negative to positive. So we have now x is equal to 2y plus 3. Substitute 2y plus 3 for x in the first equation. Substituting 2y plus 3 for x in this equation, we get 2 times the quantity 2y plus 3 plus 4y is equal to 14. Using the distributive property of multiplication, we get 4y plus 6 plus 4y is equal to 14. 4y plus 4y is equal to 8y, and then plus 6 is equal to 14. Transpose positive 6 to the other side, change its sign from positive to negative. So we have now 8y is equal to 14 minus 6. 8y is equal to 8. Divide both sides by 8. Y is equal to 1. Substitute 1 for y in the second equation. X minus 2y is equal to 3. This is now equal to x minus 2 times 1 is equal to 3. X minus 2 is equal to 3. Transpose negative 2 to the right side. Change its sign from negative to positive. X is equal to 3 plus 2. X is equal to 5. So the value of x is 5 and the value of y is 1. The solution is 5, comma 1. 5 here is the value of x, 1 is the value of y. Let us check. 2x plus 4y is equal to 14 is the first equation. X minus 2y is equal to 3 is the second equation. For the value of x, we got 5, and for the value of y, we got 1. We substitute 5 for x in the first equation and 1 for y also in the first equation. So, we have now 2 times 5 plus 4 times 1 is equal to 14. 10 plus 4 is 14. 14 is equal to 14. This is a true numerical statement. Next, substitute 5 for x in the second equation and 1 for y also in the second equation. So we get 5 minus 2 times 1 is equal to 3. 5 minus 2 is equal to 3. 3 is equal to 3. This is a true numerical statement. This means the value of x is really equal to 5 and the value of y is really equal to 1.